I'm Annie Sigmund.
And I'm Abby Torno.
And our proposal, Bioskins, questions how architecture can bridge a gap between biology and technology. Our design is a space that looks to biological processes to construct sustainable and efficient building skins. At the simplest level, an architectural building skin is responsible for providing thermal comfort and protection to its users. But what if a building skin was able to provide more for the user's needs? Our site is located in Des Moines, Iowa at a historic Union Depot in the East Village. The depot was constructed in 1909 and connected to the Wabash Railroad. This transportation point linked to other cities to spread knowledge of new materials and technology. Throughout Des Moines, we see a range of building skins that have become architectural icons for the city. From the insulating copper glass at the Chipperfield Library to the gold-gilded dome at the Capitol. What if we widen the range of building skins throughout the city and use today's knowledge of computation, technology, and science to maximize efficiencies and sustainable practices? Our architectural proposal allows a space for experimentation of smart building materials.
The existing depot will remain on the site as a dependent variable in our experiments. Our new addition will provide a framework to showcase and test building facades as well as introduce them to the public. Our building houses robotics labs, education classrooms, and a public cafe. The site has direct access to the old railway, which the city is looking to convert into a bike path. This allows good public exposure to the pavilion space. We have organized our building to maximize our surface area of the south facade, where our building skin experimentation will occur. The south facade is important due to the access to sun throughout the day and summer ventilation. We made a bar on the north of our massing for all of our servant spaces, such as mechanical, bathrooms, and circulation. This allowed us to utilize the south of the massing for public spaces. Our building's different levels of public spaces act as a gradient from our main entrance at our lobby to the private labs of the third floor. On the right, you see our main entrance into the building. This is where our lobby and our shop are located. This also includes a storefront of the existing depot that houses administration offices. Further into the center of the building is our public cafe and dining area, which has great access to the outdoor pavilion. The second floor has our education classrooms and research team workspace. We have robotics labs on each floor oriented to the south.
Our structure reflects a servant versus served organization with a shear wall core along our north and columns for experimentation on the south. The shear walls oriented north to south outline our mechanical zoning. We want to utilize thermal chimneys inside these walls to passively cool our cafe and dining space. The structural grid divides our south facades into set dimensions for our experimentation plots.
In order to test each facade under different variables, the building skin plots are on hydraulic systems that allow them to be moved and tilted. The hydraulic system also allows the facades to be retracted in the robotics lab to allow for easy installation and replacement. The corner detail within the robotics lab shows the construction assembly of the hydraulic building skin system. In this location, we are testing the building skin for its enclosure and thermal abilities. To accurately assess each system, we need a controlled environment within the lab spaces. After the system has proven to provide these basic needs, the system is uninstalled in the lab and installed in the public spaces. Here we want to test how the system will respond with the public and test its atmospheric qualities.
Because there is a wide range of building skin technology, we created categories to specialize our research. The categories are air filtration, water management, and thermal comfort. We chose these because they are important environmental variables of sustainable architecture due to our changing climate. These building skins reduce the energy consumption of the building by integrating science and computation to create innovative ways of neutralizing pollutants, collecting water, or passively cooling. These facades are not meant to be permanent on our site. After experimentation, knowledge of these building skins will be distributed across Des Moines and Iowa. Historically, Iowa has grown and distributed products of agricultural plots. The industry has embedded a horizontal organization on the land. Our project is meant to grow and distribute the products of architectural plots. We wonder how this can change the landscape of the built environment.